Again, this is Teacher Aimee. Before we begin with our lesson, please prepare with you your textbook as well as your pencil. I am hoping now that you're holding with you your textbook as well as your pencil. If you have highlighter, that would be better. So open it on page 329 to page 334. Now focus on page 329. Looking back with our previous lesson, when we say inference, we are doing what? Yes, we are making conclusions. So this morning we are going to compare or comparing. So compare conclusions in a given population. Our objectives: use box plots to compare and make inferences about populations. Use the median and the interquartile range of datasets to informally compare and make inference about two populations. Let's have a review on how are we going to display a data. So there are three, right? So you'll have dot plot, tables, and box plots. All of these three displays a certain data of a population. So how does a dot plot look like? It looks like this. How about a table? Yes, it looks like this. And how about a box plot? It looks like this. So this morning we are going to focus on a population illustrated by a box plot. So we're going to compare certain population using a box plot. Okay, let's take a look on your previous knowledge on how does the box plot is being created. So you have 10, 2, and the rest of the scores. Our numbers is what we call the data of a certain population. Now, arranging the score from 1 or the numbers from 1 to 12, so you will arrive 1 is at lowest point and 12 is the highest point. So therefore, if 1 is the lowest point, so that is our minimum value, and 12 is our maximum value. Now, how did we arrive at the median here? So as you can see, counting from 1 until here, the middle, you have 6, and from 12 until here, the middle is at 8. So you cannot have two middle values, so you get the average. So you have 6 plus 8, you have 14, divide by 2, so you will have the median is at 7. Now, we are going to determine our Q1 and our Q3. So from here, let's determine our Q1. So let's count. From the 6, what is the middle? From 6 to 1. So you have 1, 2, 3. We'll stop. And count also from the 6. 1, 2, 3. So where did we stop? We stopped at 2, right? So therefore, 2 is our first quartile. Now, let's take a look with this one. From the 8, what is our middle value so that you can arrive our quartile 3. So you'll have from the 8, you will count 1, 2, 3. And here also from the 12, count 1, 2, 3. So the middle is at 9. Therefore, our quartile 3 is 9. I hope you understand how are we going to create a box plot.
The essential understanding for this lesson is box plots and other data displays can be used to informally compare and make inferences about two populations. You can either compare the shapes of the data displays, or you can use measures of center and variability. In previous lessons, students learned how to display numerical data in box plots and dot plots, and gave quantitative measures of center and variability. This lesson extends student skills to applying their knowledge of data displays to compare and make inferences about two populations. This problem is key because it presents two similar box plots that each describe a population. Students analyze the box plots to infer how the populations are alike and different. Begin by asking students to compare the medians for the two datasets. Listen and look for students who compare the positions of the midlines of the rectangular parts of the box plots. Each midline shows the median, and the median for animal 2 is greater. As students complete Part B, ask them to explain the meaning of the term variability. Listen and look for students who describe variability as the spread of the data, or its variation from typical values. The box plots show that the data for animal 1 have the smaller range, or difference between maximum and minimum values. The data for animal 1 also have the smaller interquartile range, which is shown by the span of the rectangular part of the box plot. A small interquartile range shows data that are closely clustered around the median. So there is less variability in the data for animal 1 than for animal 2. Next, ask students to justify their answer to Part C. Listen and look for students who explain that the median is greater for animal 2, as is the first quartile, and the third quartile. For these reasons, animal 2 generally eats more food than animal 1. Listen and look for students who disagree with this conclusion. These students may point out that animal 2 produced the lowest value in either dataset, which is 25 pounds of food. Explain that the box plots represent data obtained each day for 1 month, or about 30 values. Animal 2 ate less food on at least 1 day, but likely ate more food than animal 1 during.
So in this problem, ALA surveys a random sample of 27 graders. As you can see, you have A to T, and mostly of the data shows it has 1 sibling, 2, 3, 6, and you have also 0. What the 0 means, the only child in the family. So you're going to draw a model to show how ALA can best describe. So the minimum value at 0 and the maximum value is at 6. Where is the median? Yes, the median is at between 1 and 2. So therefore, our box plots look like this. What measures of variability are used when comparing box plots? The range and IQR are used when comparing box plots. The range and the IQR described variability or spread of the data.
How can you use data displays to compare populations? Think about this question during the lesson. Finn and his cousin Jonah attend different middle schools. They compare the number of hours students at each school spend on homework each week. Finn and Jonah each conduct a random sample of 20 students who attend their schools, and then list the data in order from least to greatest. What can Finn notice about the time spent on homework? Finn's first step is to display the data in box plots. Before he can construct either box plot, he needs to identify the median and quartiles for each data set. The box for Finn's data set is between 3 1/2 and 6 1/2. The median is 5. The box for Jonah's data set is between 5 1/2 and 8. The median is 7. Which measure of center is more useful to describe Finn and Jonah's data sets? Why is the median a more appropriate measure than the mean? The median best describes the data because both data sets have outliers. The next step is to compare the two data sets. The line for the median of Jonah's data set is to the right of the line for the median of Finn's data set. So Finn can say that the median of Jonah's data set is greater. The box for Finn's data set is longer than the box for Jonah's data set. So Finn can say that his data is more spread out or has greater variability.
I hope you understand or get something on the problem number 1. So let's try this one. Try it number 1. Now looking at the 6th grade students and the 7th grade student, this is their height in their box plot. Now you will have the median is here, and the second median for the 7th grader is at this one. Now compare their medians. The median of the blank is greater. Which median is greater? Is it the 7th grade or the 6th grade? So you will have the 7th grade. So it's greater than the median of, correct, in the 6th grade. So therefore, what can you say about the two data sets? The blank grade sample has greater variability. How will you know the variability then? It's after the median. So which box is longer? Is it after the median? Is it the 7th grade or the box on the 6th grade? So you will have 7th grade.
Finn and Jonah analyzed the measures of center and variability of the data they collected. Finn noticed that the box for his dataset is longer than the box for Jonah's dataset, and concluded that his dataset has greater variability. Do these measures support that assessment?
Okay, so let's take a look upon the box plot of Finn's data and Jonah's data. What does the line in the center of the box represent? The lines here. So it represents the median of the data. What does the median tell you about the population, by the way? So it tells about the data point exactly in the middle of the distribution. How does the RQR tell you about the population? So what does it tell you? So it tells about the variability in the middle of the half of the data. So how are we going to solve for the IQR? So you will just minus the third quartile minus the first quartile, so you will have 3. And also in the Jonas data set, 8 minus 5.5, you will have 2.5. So the median is at 7, right? Now, thus the data, okay, it's stated here, Finn noticed the box for his data set is longer than the box of Jonah's data set and concluded that his data has a greater variability. So we are going to support who has a greater variability in our data based on the black box plot. Is it in Finn's data or Jonah's data? Looking back to the IQR tells the variability. So who has greater variability? So look at the median in the Finn's data is at 5 and Jonah's data is at 7. Now, who has longer box from each of this median? So you will say, look at their RQR. 3 and 2.5. So which is greater, the 3 or 2.5? So we can conclude that the IQR of Finn's data is greater. So there is a greater variability of spread in the number of hours students in Finn's school spent on homework.
Mr. Bunsen had students grow the same type of plant in 2 different rooms to test the growing conditions. The box plots show the heights of all the plants after 3 weeks.
These are the box plot now, the room in the 7D and room 7G, the plants in there. What is the median of the 2 plants? So considering the line in the middle, here and also here, so you'll have their median is at 12.
Mr. Bunsen had students grow the same type of plant in 2 different rooms. Mr. Bunsen had students grow the same type of plant in 2 different rooms to test the growing conditions. The box plots show the heights of all the plants after 3 weeks.
Okay, so how the 2 populations compare? What inference can be drawn out of these plants? So you will see the median of the heights are the same, right? It's at 12. And the room in 7D, 50% of the plants in 7D are between 8 and 14. How did I know it's 8? It's here, right? It's 8 and 14. And The other plant also is between 10 and 16. So how are we going to compare the two plants then, looking at their median? So we are going to compute their IQR. So how will we solve their IQR then? So the first plant, you will have 14 minus 8 is equals to 6. How about the second plant? You will have 16 minus 10, so you will have also 6. Both of the two plants have the same IQR, right? So therefore, what inference can be drawn out of these two data sets? We can conclude that the plants, the growing conditions in room 7G are more favorable to the room plant in the room 7G. Although they have the same IQR, but they have also the same median, right? So we are going to consider the box plot. Which room is longer? Is it the 7G or the 7D? So you will have the longer the boxes after the median is the 7G. So it's more favorable than the plant in the 7G. So how can data displays be used to compare population? So data displays can be used to make inferences about two populations. You can use the shapes of the data displays or measures of the center and variability to compare data. I hope you learned something on the previous examples before we're going to proceed on page 332. So you will see here, the longer the data set in B than in A, they have the same median. So therefore, this data set B has a greater variability. And 50% of the data in set B are between 4 and 9, and 50% of the data set A are between 4 and 7. Okay, so let's proceed. Can you open your textbook on page 332? So the first one here, do you know? Okay. So the box plot describes the heights of flowers selected randomly from two gardens. You have garden Y and you have garden Z. So use the box plots to answer question number 4 and question number 5. Find the median of each sample. Garden Y, median is equals to, where can you find the median again? In the middle line. So garden Y has the median of 6. I hope you get it right. How about in the garden Z? What's the median? Correct, it's 4. So number 5 question, make comparative inference about the flowers. Knowing that the median of the garden Y is at 6 and knowing that the median in the garden Z is at 4. So what inference can you make? You will say the flowers in garden Y are generally taller than the flowers in garden Z. Wasn't it easy? Now let's go to number 6. These are the Rob's temperature and Anna's temperature. So look at the box plot. The median of Rob's data is blank than the median of Anne's data. What can you conclude about its data? So the median for Rob versus the median of Anne's data. You will have exactly about 0.1 degrees Fahrenheit lower than the median of Anna's Fahrenheit. So this means Rob is at greater or higher? You will say it has a higher elevation than Anne. So let's proceed to number 7. I hope you're still with me, your book and your pencil with you. Now look at the box plot, the animal 1 and the animal 2. Letter A, the median of animal 2's data is blank than the median of animal 1's data. Is it greater or lower You will have, correct, it's greater. How about letter B? Liz can infer that there is blank variability in the data for animal 1 than for animal 2. Who has the greater variability? Is it animal 1 or animal 2? Okay, so therefore, it's less variability, the animal 1. Why? Because its box from the median is shorter than the animal 2. Therefore, it's less, right? Okay, letter C. Liz can infer that animal blank generally eats more food. So based on this box plot, who has a greater median? Is it animal 1 or animal 2? It's animal 2. It generally eats more food. So in number 8, look at this number 8. The box plot shows the height of a sample of 2 types of trees. You have tree number 1 and tree 2. Now the median height of tree is greater. Which tree has a greater median? Again, this is teacher Aimee. How was your lesson this morning? Was it easy or difficult? Of course, it's easy. Now look at this problem here. You will see that the family is trying to purchase a lot in the hometown and in the Flint field. So they see that each of this one has the same median. So what is another statistical measure that the family might consider when deciding where to purchase a home? So the family might consider how much the range or RQR to determine how much the prices of home each town. In this problem, it requires a higher order thinking skills. Okay, so we have the box plot shows the daily average high temperatures of cities from December to January. Which city should you live in if you want a greater variability in temperature? Okay, first step, what you're gonna do? You will have identify the range of the 2 cities. Now, you will see that the range of the 2 cities are the same, right? So therefore, what you're gonna do? Compare their interquartile range. So you will see IQR of city X, so you will have 50 minus 30 is equals to 20. And you have the IQR of the city Y is 50 minus 25 is equals to 25. Now, compare these 2 cities. 25 is greater than 20. So, based on that one, which city you will live? You will go to city Y. It has more variability in temperature. Okay, for our last number, please read with me. Number 11, Paul compares the high temperatures in city 1 and city 2. So take note that the range in the first city is at 10 degree Fahrenheit and the IQR is at 5 degree Fahrenheit. In city 2, the range 20 and the IQR is at 5. So what can you conclude about the weather pattern in the city based on the ranges and the interquartile range? Now, if you get this answer correct, it means you understand very well in our lesson. The correct answer is exactly. I hope you enjoy our lesson this morning. Once again,